1/2 x squared. Domain. The domain of any polynomial is all real numbers. Negative infinity to positive infinity. Now, we can use the exact same method we were just using from left to right. Over here on the left, it keeps going. If I zoom out, I'm going to see graph continuing to go in all directions there. So it has no starting point. It has no stopping point. So that's why the domain here is all real numbers. Range, y values, start at the bottom. We don't have anything. We don't have anything until we get to a y value of 0. So our y's are greater than or equal to 0, or 0 to positive infinity. Your interval notation will always be least to greatest. So 0 is smaller than positive infinity. Negative infinity is smaller than positive infinity. So it's always least to greatest if you're ever in doubt of what order that should go in. The y-intercept, where we cross the y-axis, is the origin. So this one's 0, 0. Guess what? That's also our x-intercept. Now, increasing, decreasing. The two examples that we've done so far, they've both always been decreasing. There's not been a change. But if we look at this graph from left to right, if we are following the function, it decreases first and then it starts increasing. So this is what I encourage you to do when you're doing increasing, decreasing problems. Find that point where it changes. Well, we just marked it because it's also the y and the x-intercept. That doesn't always happen. It just did in this case. Find that point and draw yourself a vertical line through that point. Okay, whatever point it is where it changes from going down to going up or vice versa, draw yourself a vertical line so that you can see, okay, over here on this side, I'm going down the whole time. Over here on this side, I'm going up the whole time. Because there will be functions that we look at that change several times. We're just looking at a simple example to start with. And I want you to write down the x value where you drew that line. So the x value where we drew that line was 0. And over here on the left, I want you to put a negative infinity, and over here on the right, I want you to put a positive infinity. Essentially what we're doing is we're creating a number line, and we're going to label it. We're going to say over here on the left, my function is decreasing because it's going down as I look at it from left to right. Over here on the right, my function is increasing because it's going up as I look at it from left to right. Now, the reason why I do all this is because it makes writing the increasing and decreasing intervals very, very simple. Decreasing, all you have to do is take the negative infinity and the 0. Then it is increasing, you got the 0 to positive infinity. It's written right there. All you have to do is take the numbers and put them in an interval. Negative infinity to 0 is decreasing. 0 to infinity is increasing. It makes it very, very, very easy if you use that convention. Okay, extrema. This one has an absolute minimum. It has a very lowest point that it hits, and that point is the vertex, which is also the y-intercept, which is also the x-intercept. They're not usually always the same thing, but they are in this case. Now, we haven't talked about this with the other functions because they didn't have one, but this function has an axis of symmetry. It's actually that line that we've already drawn. That cuts that parabola directly in half, does it not? And the equation of that line is x equals 0. It's a vertical line, so vertical lines are x equals, X equals 0 is the axis of symmetry. And if you didn't know this already, let me point this out. In Desmos, you can graph x equals lines. It doesn't always have to be y equals. I can graph x equals 0. I point that out because what if they're asking you what is the axis of symmetry? And you're not quite sure, but you can reason through it enough to say, okay, well, if it's symmetry, it's got to, cut my function in half. So, if x equals 3 was one of the choices, graph x equals 3, obviously that doesn't make sense, right? So that's why I want to point that out. You can graph x equals in Desmos. It doesn't always have to be y equals. All right, last thing in behavior. Look at the left side first. As x approaches negative infinity, that is the left. Look at the left side of our graph. The left side of our graph is going up. Up is positive, positive infinity. As x approaches positive infinity, that's the right side. Look at the right side of your graph. Where's the right side of the graph going? It is also going up. So it is also positive infinity.